For those of you who just joined, welcome to today's lecture, and we're gonna create an elastic Kubernetes cluster, Amazon EKS cluster, and run our first Kubernetes sample Kubernetes workload. I will remove all these unneeded things, basically everything but provide the TF. Level 1 is already applied, and we already have a VPC out there. That is fine, that is good. Only thing we'll do is we will add some extra tags for our VPC. And let me do this. These tags will be required for us later for Kubernetes to discover these subnets and put required workloads properly on a Kubernetes level in these subnets. Kubernetes will discover subnets tagged with proper tags and will reuse it in its own, I'd say, API. Probably we don't need environment code. No, let's move forward with them and be explicit. Yeah. So now, with once Terraform destroy is done here, we will apply our VPC changes, and while we're still waiting, we will start creating the cluster itself. The resource is called AWS EKS cluster. Very simple. And perhaps I deleted too much. We needed a data source. Let me recover it from Git. Very simple. EKS requires several VPCs. In our case, these will be private VPCs. It requires a name, and it will also require a role that we'll also create. Allow me to copy paste assume role policy. And pay attention here. This role is assumed not by EC2 instances. It is not assigned to EC2 instances. The EKS service will be using this role. This means in assume role in assume role policy document that describes who can use this role. We should specify EKS. Very important. Otherwise, nothing going to work. And we need to attach several policies to it. These are managed policies maintained by AWS automatically for us, similar to S3 full access policies. There will be so-called EKS cluster policy that basically allows the control plane to create nodes for you, to create load balancers for you, and all these things. So there will be cluster policy, and also, yeah, let's attach it to the role. And a so-called service policy. It's attached to separate resource called EKS service, Amazon EKS service policy, and also attached here. And there will be separate IAM role. This time, notice the difference. It is given to EC2. That's for EC2 instances. This is for worker nodes. In Amazon EKS control plane, all these scary things about etcd and backups are done by Amazon, and but we still have to manage Kubernetes workers where actual pods are running. This means there will be autoscaling group. This means this autoscaling group needs to have some certain permissions, and these permissions are also managed permissions. There will be a worker node policy that allows a worker node to talk to control plane and connect to the node. There will be container registry. This allows to pull containers from private container registries. There will be CNI that allows to interact with networking, that allows managing network drivers. And let's frame it this way. Let's rename it to control plane. Yes. Let's create the IAMTF, a separate file, and move our policies over there. I will save this. I will save that. Now let's create the node group. I will also deploy it to a separate file. Source AWS EKS node group. What this resource is doing is it abstracts basically an auto-scaling group. So we create this node group through, I would say, EKS part, through the EKS interface. We are telling a cluster like, please create this node group for us. And this cluster is taking care of deploying launch configuration or launch template and managing your auto-scaling group. We'll give it a name. We'll connect it to cluster. We'll connect it to our node, to our role. We'll put it into our subnets. AMI is done slightly different. We just need to specify AMI type, and it will pick specified AMI that's exclusively designed and baked to run as an EKS node. Let's type on demand. Size, let's say 30 gigs. Instance type will be E3 medium. There will be a block for scaling config, basically like min, max, and desired state. Let's have at least several nodes. Hopefully my bill will survive this. So we just, that's a cluster that there is no point in running it in a single node. And again, this one is only for worker nodes. We're not managing control plane. We just can sit back, relax, and do nothing in regards to control plane. That's managed by Amazon, similar to how RDS will do this. Talking about RDS, very good, it was destroyed. And let's run Terraform apply with to create our EKS cluster. I forgot to paste RN. Here it is. And it, of course, should go to private subnet IDs. And the proper, private subnets. Very good that I made this mistake. I mean, wrong name of subnet. If we have put this into public subnets ID, into public subnets, we could have had a lot of trouble trying to figure out why it is not working. So EKS is a heavy resource. Kubernetes, it takes time to provision EKS cluster. If you do this hard way, it will take weeks and weeks. But Amazon luckily automated this a little, but it still takes time. It will take like 15 minutes. And right now, I suppose it's perfect time to ask questions. Boris, yes.
I noticed you put the capacity type on demand. Is there other capacity types? I haven't looked it up myself yet.
There is spot, but basically there are on demand and spot. Spot means if there is unused capacity in AWS, you can negotiate the price. You can buy it lower than on demand, and this price always changes, like supply, demand, and market. Like market price for a local lobster in the restaurant. And if this price goes higher than your maximum bid, this instance will go away from you. That's basic, by the way, really a neat feature, especially in Kubernetes, because in Kubernetes, if a node goes away, the deployment is automatically redeployed to some different node that you have available in your cluster. And you don't have to care about like writing user data or whatnot. You just package and it as a container, pull container, run it as a deployment, and Kubernetes will manage all high availability.
That's pretty awesome. Thank you.
Yeah, and disclaimer. Next session will be difficult for majority of people, especially for ones who don't understand Kubernetes. But I'd say it's just, I would say, an introduction, and it is okay that you, after this first encounter with Kubernetes, you still have questions. I'll try to explain as much as I can, but by itself, Kubernetes is a topic that we need more than 21 days to learn Kubernetes by itself. Yes, Boris.
A little bit off topic, but not much. Like in your professional life, would you say, do you ever have to present what the cost is going to be, what the spend is going to be for a solution that say you're given to deploy, or that's not your?
You mean forecast the bill, forecast the?
Yeah, like say you're sitting in a meeting and they have a project for you and you have to deploy a solution.
Mhm.
Do you get involved in that at all? Like, do you have to
Of
calculate that?
course,
You do.
yes. It always depends on the setup. For example, in enterprises, there are separate people who do the architecture for you, including cost estimations. But in smaller companies, you might be the only person both doing design and planning how much this is gonna cost, and so on. But you should never forget that there are significantly more variables into the final cost, and for example, traffic, amount of traffic you're serving, impacting a bill significantly. For example, in our case, traffic is like 50% of the bill in my current full-time job. Um, but yeah, there are solutions like perhaps I have one installed. Let's try infra cost. No, we don't have infra cost. Let's install it in the meantime. Oh no, there is another command that will take ages. No, it was rather fast. I thought previously it was like client only. Maybe that's not infra cost. 1 sec. Anyways, you get the idea, and that's the tool. That's the example. But it will take slightly more time to register and plug in there. But overall, it will show you directly based on your Terraform code how much the infrastructure approximately will cost.
Wow, I didn't even know that existed. That's pretty cool.
Okay, cluster itself created. Now it's creating a node group. Let's check in AWS console. We can go to EKS. Here's our cluster, Kubernetes version 1.26. We can go to compute. We already have these finance workers, status creating. If we dive into here, we can see the nodes. It don't yet have any nodes. If we go to EC2, we might already see auto-scaling created for us, and let's see if we have it. Yeah, here we are, EKS, min, max, desert, and we did not create auto-scaling ourselves. We created a node group which instructed AWS, since it has proper permissions through the IAM role to create this auto-scaling group for us. Yeah, it seems created. So let's now connect to our Kubernetes cluster. So first command I'll run is AWS EKS list clusters. Sorry, my AWS CLI broke. Let me fix it real quick. I'm using a tool called ASDF. Why it is cool? Because it's a package manager for popular command line tools which supports versions, and most importantly, it allows you to quickly switch between versions. If, let's say, one of your projects use Terraform, I don't know, 1.15, and another project use some old 0.14, you can just use either ASDF to switch between them really quick without having to reinstall everything again and again from scratch or maintain multiple binaries or something like that. I recommend it very much. Okay, so the command is AWS EKS list clusters. We have one. Here is our finance. Let me do some minor readjustments prior to we do this. And the second command is AWS EKS update kube config and -- name, which is our cluster name. What it's done? It automatically created a kube config file, and let me even show it to you. So what is kube config? Kube config is like your SSH key, but for Kubernetes. It contains information about to which endpoint you connect, some secret authentication information. So this one is horribly compromised, and I will for sure delete this Kubernetes cluster after I'm done, so the key is no longer used. And some additional authentication parameters, and stores it in. It just created this file into .q into my home directory .q/config. So I can delete everything again. Empty file. I run this update kubeconfig command. Now I have this cluster authentication. Very, very convenient, very handy. And from here, there is another command that you'll need to install on your laptop is kubectl. You can run kubectl get nodes, for example. Yeah, my SDF is giving me a hard time. SDF global kubectl 1.18.0. And there we have it, our 3-node cluster. Let's run something on this cluster. Let's say we want to run nginx. kubectl create, and again, that's not a Kubernetes class. Just follow along these commands. They don't really matter too much right now. So what I did is I created a deployment of nginx. That was the correct command, and scale it to 5 replicas. Now I can run kubectl get deployment. You can think about deployment like you think about autoscaling group, and we can run kubectl get pods. Here we are, 5 replicas, 5 pods of our nginx, and you can think about pods just like you think about instances in your autoscaling group. Let's try to connect to this nginx. So the command expose creates a Kubernetes object of type service. And you can think about service just like you think about a load balancer. So in Kubernetes, service is an abstraction that distributes traffic across multiple replicas, across multiple pods. And there are multiple service types. The one that we specified behaves very interesting. It sends an API request to special Kubernetes component called Cloud Controller Manager. this cloud container manager within Kubernetes internals, it's managed by Amazon, is through IAM role that we assigned and gave it through EKS cluster role, interacts with API of AWS, and through Kubernetes interface, we are creating this load balancer. That's a load balancer. Let me show it to you in AWS. Load balancers. Here we are. That's our load balancer. We did not create it with Terraform. We created our Kubernetes cluster with Terraform that creates and manages load balancers for us. Let's try connecting to it. HTTP. Welcome to Nginx, which is served from our Kubernetes cluster. So yeah, that's how we do this. That's how we create sample Kubernetes cluster. And what I will do is make sure I delete everything. This time both from Kubernetes. Let's create a branch. I make sure I never forgot to run Terraform destroy again, because EKS is slightly more expensive, and if I leave it overnight, this will be more significant hit to my budget. And create a pull request and make a merge. Yes, Ritika. And sorry, before you proceed with your question, for now, we are finished for today with the lecture. I will stop recording and open